is John Foltz, the marketing director from SST. He's got more than 20 years in the flexographic printing industry. He has experience in leadership positions in product management, product marketing, and business development. And John has a Bachelor of Science in Finance and an MBA in Marketing, in addition to multiple printing and quality certifications. John, it is all yours.
Thank you very much. I appreciate it. And good afternoon or good morning to everyone on the West Coast. I appreciate you taking a few moments today to learn a little bit more about this unique LED technology. A little bit about SST in general, and then talk about some key technical differentiators of this LED technology. You'll hear me use the word conventional LED quite a bit throughout. By conventional, I'm really referring to all the other LEDs that you've seen on the market up until this point. Slight differences in each of those, but really the construction and the design is very much similar. Or what you learn about ours is there's a significant difference in the design. Then we'll talk about what actually some of the results of those differentiators and how that's really disrupting the FLEXO printing industry in particular. And then look at it, just a couple of customer examples at the end, and talk about some actual numbers and what they've experienced after they've started using the technology. And then, of course, there'll be a Q&A, which is after both of our sessions here today. So first, a bit about the SST, the basics. We've been around for 27 years, all with LED innovation, vertical manufacturing and integration. We're based in Lawrence, Kansas, so proud to be a U.S. company. And geographies served to date include really all of North America, Mexico, Europe, South America, South Africa, and the Middle East, and continuing to expand as LED is really gaining adoption globally now. From a product and market standpoint, initially SST was really about industrial and commercial lighting systems back in the early 2000s or late 1990s actually. And then did some infrared laser technology for use of high-speed train applications, and several projects for NASA, having technical things that were approved. And in fact, just recently learned we've got a fifth one that's now pending to work with them. Again, all around LED type of technology. But in the mid 2000s, this is what's relevant for today's conversation, is the LED curing system. We've got 5 patents on this design. It works very well in a lot of printing environments, including FLEXO, screen, offset, and digital. Compatible now really with all the major ink and press manufacturers. I do want to mention here, some of you may be aware, initially the technology was only available through an exclusive agreement with Fujifilm. That ended now a year and a half or so ago. And we've been working really now with all the ink companies as well as press companies, and happy to work with anybody to get the technology out there. For FLEXO, primarily we use 395 nanometer wavelength, but we do have the ability and do sometimes use 385 and 405 for custom type situations. And anything from what we call single up to quad power. Typical FLEXO applications now are single and double. But for some specific application, we need to even add a little bit more power. We certainly can do that. That's more commonly used like in offset or in digital applications. We've now done over 200 FLEXO press installations, both retrofit and an OEM standpoint. So there's a lot to go through, but want to talk really about the primary things that differentiate us from the other conventional LED systems out there. This is a picture of one of the standard FLEXO type housings. And you can see the blow up here, a little bit tough to tell in the picture, but these are rounded glass quartz domes. So instead of 2 flat lenses, what you generally see on conventional LED, we're using a single rounded dome, and that has several impacts here. The first is the patented heat management and domed lens technology compared to the flat gives us a very high efficiency, really the highest efficiency on the market, lowest energy loss. So we get very, very little reflectivity from this design, as opposed to flat lenses where much of the energy gets reflected and doesn't end up at the surface of the ink to do the cross-linking. And also, and what's also very unique then is we also produce very little heat with this technology. And that's really one of the biggest differences between us and the other systems, whether you're UV today, conventional LED, water-based where you're drying. All of those systems produce a lot of heat. We've all dealt with that for years. We're just used to dealing with heat in the printing world. What's different here is it's the first technology that's almost eliminating heat from the printing process. So we'll talk about what that all means here in a few minutes. And then the second main piece is that it's also a much wider system. Because we use so little energy and we produce so little heat, we're able to make make it simply a wider exposure range here. So if you imagine the substrate running underneath this light system, there's a lot more time for that ink to be exposed to the energy and do the cross-linking process. So those are the two key things: the rounded glass domes and the wider situation, or the wider exposure time. So we'll talk now about some of the paradigms that are being changed in the printing business by what that technology delivers. First is equal or more curing dosage while still producing very little heat. This chart to the bottom left, I'm not going to go through it in great detail, but it shows the dosage curve. The blue is the SST LED technology. So the area under that blue curve is dosage. It's a combination of watts per centimeter squared and time. That's what determines how well you can cure FLEXO ink. The more dosage you have, the better you can cure the ink. The area under the red curve is conventional LED. Again, all of them are fairly similar to this. Some may be a little bit higher, some may be a little bit lower. On the right-hand side is temperature. So you can see conventional produces a lot of heat. That's why they have to cool their systems and use chill drums in order to remove that heat and not affect heat-sensitive substrates. The left-hand side is UV intensity, watts per centimeter squared. And you can see typically conventional starts maybe around 16 at the lowest end and goes up into the upper 20s. We're between 5 and maybe 8 watts per centimeter squared. So very little energy needed to drive our system because there's so much more exposure time, which is what you see on the bottom of the graph. We have from the center of the light source there, significantly more exposure time. So even though we're using much less energy, we produce actually more dosage than you do with conventional. And we have the ability, as I said, to even increase that if we need to, and also producing very little heat. The second big paradigm is the lowest maintenance and highest productivity of any print technology. Literally to do the maintenance on the system, it's just changing a couple of things that I'll talk to here in a couple of slides down the road. But by far it's the simplest and easiest and least amount of time you'll need to maintain or service the system as compared to any conventional LED, UV, or water-based drying system. The third then would be that lowest energy cost, and of course along with that is the lowest carbon emission output. Because we're using so little energy, we're able to significantly reduce the energy needed to drive the system, even more so than conventional LED. And of course, along with that, much more green aspects, and I'll dive into that a little bit deeper here in a few more slides. And then lastly, the fastest payback, because we're using about 75% less energy than conventional LED. If you look closely at LED in the past, certainly several years ago, it was sometimes tough to justify due to the cost of the equipment and only saving maybe 50% of the energy cost. Now we're at about 90% energy cost with our technology savings. The cost of the equipment has come down to where it's only a slight premium to UV, where a few years ago it maybe been twice the price to buy LED. So the paybacks now, as you'll see here in a few slides, are extremely attractive. So those are the four kind of key paradigm changes. So now we're just going to dive in a little bit deeper. What does that actually mean for you guys, for the FLEXO printers out there? Number one, very low heat. It's going to drive significant capital equipment and operational cost reductions by eliminating three main things. When you think about, since we're producing so little heat, now we can really simply get rid of a few major components that we've all dealt with for many years. First is chill drums. to keep heat sensitive substrates cool. We literally do not need chill drums on the press any longer. You can run high percentage shrink film jobs without running chill drums. That's a cost of at least $80,000, if not more, on a new press, especially if you're talking about medium and larger size presses. So very significant capital equipment savings there. And then the cost for the large chilling system for those conventional LED systems, they also have to have a large, a chilling system to drive that chill drum system. So now if you have an existing press, you do a retrofit, you can literally set those chill drums to idle. Some cases you can't actually remove them, but you can set them to idle, so you're no longer using the energy to chill them and the energy to drive them. And we simply can eliminate web breaks due to heat. When you think about shrink sleeves, depending on what type of system you have, you may experience web breaks occasionally or even frequently. So web breaks due to heat are simply eliminated. The second big piece of equipment is the systems or the fans to cool conventional LED chips. So it's a conventional LED system. Because they produce so much heat, they also have to do something to cool that LED system, not just the chill drums, but also the LED chips themselves. That's also a very large chilling system, a lot of operational costs and a lot of capital costs and a lot of footprint in your plant. And then lastly, exhaust systems can be completely removed or turned off because we're producing so little heat that doesn't need to be removed. And VOCs, via the fact this is LED, it means you no longer have to do your building penetration when you're putting in a new press for ducting systems, etc. And then the capital cost and maintenance for those systems. The second main paradigm changer here is the highest press uptime, and we allow for user serviceability of the system. As I mentioned before, it's the lowest maintenance and service time of any FLEXO technology out there, less than 2 hours per month on an entire FLEXO press. The entire maintenance is to clean the lenses off occasionally, maybe every couple of weeks, maybe every 4 weeks, depending on how many shifts you run. That's literally a lint-free cloth and isopropyl alcohol, a couple of minutes per station. Refill the water circulators when they run out of water, maybe once every month or every quarter, and then clean the water circulator filter maybe about once a year. That's the entire maintenance schedule, and I'm sure you're all well aware of what it takes to maintain UV and water-based drying systems. So your maintenance time is going to go way down. Then the modular design allows for user serviceability. Unlike conventional LED with the modular sections that I spoke to a few minutes ago, we don't have to service those in a clean room environment. So if there is something that needs to be replaced or serviced, we can do that and normally have the customer themselves do it, and it doesn't need to be in any clean room environment and have you ship it back to the manufacturer, which may take, you're out of a station for 2, 3, 4 weeks, and the costs of shipping and everything there as well. So most diagnostics and service can be done on site. And in fact, we just looked at this again the other day. In the US, we've replaced less than 1% of all modules that have been placed, and our first placement now was about 6 years ago, and a little bit over 40,000 hours. So as long as you do that very basic maintenance, these things last a very long time, and you can expect very little failure. Third then is the lowest energy cost and carbon emissions. So lowest energy of any curing or drying technology, we'll say, well, you see a couple of numbers here in a moment to kind of document that. Then the energy to dry the chillers and exhaust systems also becomes zero. You literally can turn them off. Additional chilling systems for the conventional LED chips, as we talked about, are no longer needed. And then in addition, especially in hotter months in the hotter locations, your air conditioning load in the manufacturing plant goes down significantly because we're not pumping all that hot air out into the printing environment of the room anymore, which also is a nice thing for the comfort level of your press operators. I'm not going to read every number on this slide, but what we're doing here is comparing in FLEXO in particular, a typical 10 by 17 inch press running 2 shifts a day. UV arc, if you're running UV arc today for ink curing, it's about 150 tons of carbon emissions per year, 27 tons for exhausting the heat and VOCs, another 28 typically for the chilling. So you're putting about 205 tons of carbon emissions into the air every year with a typical UV arc system. With conventional LED, obviously a huge improvement down to 133 tons, but they do still have to run chilling systems here and still haven't reduced the cost of curing as much. So in the case of our technology, we're now all the way down to only 19 tons of carbon emissions per year. There really is nothing you can do if you've got customers that have sustainability initiatives or your own internal maybe KPIs around sustainability. There really is nothing you can do in a FLEXO plant that's going to have a larger impact on carbon emission reductions than changing to an LED a curing system. And then in terms of dollars per year, on that application, we're going to say it's about 445,000 kilowatts a year to drive the typical UV arc press. That's about $62,000 at the US average of almost 14 cents. If you're in California or the Northeast, you can almost double those numbers now. So the payback is even faster. Conventional LED will get you down to, I'm sorry, got one step ahead. Got one step ahead there somehow. Conventional LED will get you down to $20,000, and so a nice 67% savings. But with the SST technology, you're down to $5,000 compared to the 62, and that's where we talk about this 92% reduction in energy savings and carbon emissions. So the final piece then is the ROI I mentioned earlier. There's a lot of offsets to your investment to LED. Obviously, it's a little bit of money up front to get invested in, but you immediately, day two, start saving your 92% on your energy costs compared to UV, 75% reduction compared to conventional LED, 70 to 90% reduction in maintenance time. As I mentioned before, only a couple hours per month. The press is just literally up and running more often, spend less money on maintenance. The cost of UV bulbs and reflectors that you're constantly replacing with UV systems. And then we already talked about the capital equipment costs with chilling systems and chill drum systems. When you start taking all those numbers out, the payback starts to look obviously very attractive. And then when we factor in more productivity, in most cases we see in excess of 10%, but we use 7 to be more conservative for all the reasons I just talked about, with less maintenance, less web breaks, less issues with heat. For example, jobs that are hard to register on heat sensitive materials come into registration much faster without heat being in the environment. All those things factor into this higher productivity. So you're simply printing more billable product, per shift. And then lesser impact here, but obviously less square footage needed for a very small footprint of the equipment. And a couple summaries here on the ROI. For a typical retrofit, where we're going in and retrofitting an entire press, the payback is about 13 months on a 2-shift operation. If you're running 3 shifts, it's obviously even faster than that. And for 1 shift, it will be a little bit more than that. There are things that can impact that, and we're certainly happy to run a customized cost and use model for you and your exact situation. Just reach out to us and be more than happy to do that. For a new press, the payback is less than 3 months. The reason for that is there's only a slight premium for the SST LED compared to even UV or conventional LED. When you start saving 92% of your utility costs and have reduced maintenance, that premium gets paid for extremely quickly. So in the sense of looking at a new press at this point, it makes a lot of sense to strongly consider that a little additional investment for LED. Cost savings and productivity gains, of course, once you get that payback taken care of, whether it's 13 months, 3 months, you're going to then save those, get those cost savings again for the lifetime of the system. So last couple of slides here, I want to show you a couple of kind of real life examples. This is a typical, very old Comco Proglide press that was retrofit 3 years ago now. The press is 2004. It was a 8 by 16 typical FLEXO press. You can see the large UV units back here to drive the power, a chilling system, of course, all the electrical and the exhaust systems here. We've all seen the back of a press like this 1,000 times. Once we did the retrofit with our system, the back of the press now looks like this. The entire footprint to drive our system is here. This is the power supply and the main control box. There's a water circulator here. Again, we're not chilling the water, so it's a very small unit. There's one of these on the other side. You just can't quite see it the way the picture was taken here. And of course, also all of the exhaust tubing has been removed because they no longer need to run the exhaust system. So much cleaner working environment, a lot less noise as well because of the exhaust system being turned off. This was another retrofit, same account, different press though, Aquaflex press, again, 2004, 8x20. That was UV and running shrink sleeves as well. This is just a depiction kind of all the equipment that they took off of the press, including this is a large chilling system they had to use to keep the substrate cool. And they've now repurposed that. It's removed off the press altogether, using it somewhere else in the plant on a new piece of equipment they got. It was altogether consuming 205,000 kilowatt hours per year between the UV system, exhaust, and chilling, and about $30,000 in terms of energy costs. This is in the Carolinas where energy costs are actually fairly low. If you're running, and also I should mention this is a single shift. If you're running double shifts, you can simply double all of these numbers. And if you're again on the West Coast or in the Northeast in particular, they're going to be, you can almost double those numbers as well. And so all that was replaced with, this to drive the system, 17,000 kilowatt hours per year, $2,400. Of course, a very small footprint. The entire system weighs less than 500 pounds. And then the other benefits here, eliminating heat and noise, like we've already discussed, and still running shrink sleeves, but with no chill system even attached. Last example here, just to give you a little more, if you're not familiar with what the chilling systems look like, this was a recent one we did at a company called GPG Genflex in Atlanta. It's a large converter. I think they have 5 FLEXO presses there, as well as some digital and offset. This is a picture of the chiller that they have to use for their chilled drum system. This was on a Marcandi P7. And then here's the same type of a chiller used to chill the LED lamps. This company had put in a conventional LED system, I think it was 2020 or so. And so that system was installed in order to keep the LED system and the chips cool. This was the power supply for the LED system, just to give you an idea what that looks like. And here's power supply. That press also had water-based drying capability. And to give you an idea, just the size of the equipment needed for water-based drying equipment, also very large. In this picture, I was a little bit busy, but wanted to give you some perspective. Where these two chillers were in a separate room, they then piped the coolant up through the ceiling, across the ceiling, and then down here to the press. I'd guess 150 feet away. There's a return and a supply line here for the coolant for the chill drum system, and then also a return and a supply line for the coolant of the LED chilling system. So obviously a lot of equipment involved, a lot of expense involved, and a lot of footprint involved. And then lastly, I wanted to mention here, we did a test by turning the chill drum system off for, I think it was about 10 or 15 minutes. The temperature at the last station of the substrate, this is the last station where it would be the hottest, was up to almost 130 degrees. It was still climbing. We turned it off there because they did not want to break the web, obviously. But we wanted to be able to see, okay, how hot does the system get if you don't have chill drums? They did sell the chilling system running for the LED system, of course, but not for the chilled drums. So we're going to compare that to the press then after that was retrofit. Again, here's a small footprint of the power supplies for the SST system, 6-station touch screen, just what it looks like kind of on the press. And you can see here they removed all the ducting off of for the exhaust system, and the 4 supply and feed lines are still there, but they're not having to use them, not even use those anymore. From a temperature standpoint, with this was just the ambient room temperature of the same white substrate, just so we know we're comparing apples to apples. Typical air conditioned environment, they're 74 degrees. And then again, with no chill drum system running at all, even after a long run on the job at station 6. So really the same place as the prior picture. We're only at 83 degrees on the substrate. So literally that's how we're able to print shrink sleeves without using chill systems, because the LED system produces so little heat. So last kind of summary slide here. This is some feedback from that customer in particular, from the general manager there. They claim the maintenance time is reduced to 2 hours per month from 40. Admittedly, they had a little bit of an older UV system there that needed some additional maintenance, but that's not uncommon when you start talking about UV systems that are, maybe older than 5 years or something. The heat they used from UV water-based drying and LED is all gone. They talk about how much cooler it is to be press side. They no longer have to send the LED stations to the manufacturer for service. As I mentioned, one of the other presses had been retrofit, and they averaged sending 2 stations per year back. They were out, basically without those stations during that time, and weren't provided, a backup. Much easier to install, navigate, and maintain this system. They're actually experiencing a little bit faster speeds than they were when they were running UV, and 25% faster compared to water-based jobs. I already mentioned the much quieter working environment and the small footprint, and they're in the process now of ordering a new press that won't have the additional cost of chill drum systems or the cost of an additional exhaust system. So that just wanted to give you some perspective really from a customer's viewpoint there. And I think that'll cover it for my part of the presentation. I look forward to any questions that you might have at the end.